Hello, grade 7 students. This is the second video for this unit entitled Substances. So for this video, we are going to learn about the different states of matter, such as the properties of solid, liquid, and gas. So when can you say that an object or a substance is solid? When can you say that an object, substance is a liquid? Or when can you say that a substance or object is gas? And finally, I also have a short activity for you as a recap of our lesson for this video. Okay, so before I start, I would like you to get your Mastering Science 1A book and please open there and go to page 4 and 5. So page 4, that's our lesson for this video. And then for page 5, that is little experiment. So speaking of experiments, so I already prepared some of the materials here. So you will find out later on how do we use this one. Okay, so these are not drinks. These materials that I have will be used for the experiment. Okay, so also don't forget to prepare your pencil and your pen so that if you would like to write something in your book, you are free to do so. Okay, so grade 7, are you ready? Okay, so let's start. So let's have a short review first on what is matter. So matter, so according to the first video, so matter is anything that has mass and takes up space. And also for the previous video, so we learned also about the physical properties of matter, such as your mass, volume, your weight, your conductivity, your density, your boiling point, your melting point. Also, you've learned from the previous video about the chemical properties of matter, such as like the ability of a chemical or substance to react with water, acid, bases, or also with your ability of the substance to catch or make fire, your so-called flammability. So next, so we will be dealing now about the states of matter. So I think when you were like in grade 1, grade 2, until you reach grade 6, you've been bored of learning about the states of matter, the solid, liquid, and gas. If you're going to have your book, oh, what is this? This is a solid. Oh, what is this? What's inside the glass? It's a liquid. So yes, we've learned that one when you were in your younger years. But as you reach grade 7, we will be dealing now on those particles. Again, particles that you cannot see using your naked eyes. So we cannot just see them. We need a device in order to see them. So we will be dealing on those particles. So let's define first what is the states of matter. So states of matter, it means the form that the matter is currently in. So you will be asking yourself about this question, how does it look like? How does it look? Does it, shall we say, what's the shape? Is it a circle, a triangle, a square? Okay, what else? How does it taste? Does it taste sour? Does it taste sweet? Does it taste salty? Or how does it feel? If you're going to touch this one, so if you're going to touch this one, is it rough? Is it shiny? I mean, slippery? Is it slidey? Okay, and then what else? How does it smell? So how does it smell? Does it smell bad? Does it smell good? So whatever is your answer there, it has something, it will give you an idea on what is the form of that matter it is currently in. Before we go to the different states of matter, so let's have first a short lecture or short discussion about this kinetic theory of matter. So do you remember what I told you about these particles? So I think you've met this one when you were in elementary, when you were like in grade 5 or grade 6, I'm not sure. Or if not, I think you've heard about this word like your atom and then also your molecules. So these are the particles that we are going to deal in this video. So as you can see here, a short animation of these particles. So you have different colors like red, the green, the blue, okay, and some white there. So these are the particles wherein these particles can't be seen. Again, cannot be seen using your eyes. So we have to use a device. So can you guess what is this device? It starts with letter M. Okay, so this is what you call your microscope. So a microscope is a device used to visualize tiny objects that cannot be seen using our eyes. Okay, so I think when we deal about our lesson in cells, so you will be able to know how to use this microscope. Okay, so I think that is around unit 2 of the book. So I think maybe probably like next month. Okay, so these microscopes are used to see these particles moving around. So please take note, matter is made up of particles which are in continual random motion, continual random motion. So meaning these particles, they don't stop moving. They don't stop moving. So meaning it's either they move very slow or they move very fast. Okay, so as they move faster or even if they move slowly, they keep on bumping on each other. They keep on like bouncing or hitting each other. That's the reason they move randomly. That's the reason they don't stop from moving. Okay, so next. So from this, scientists were able to classify matter based upon the arrangement of the particle. So what do you think does the particle look like? And then another classification is from its energy of the particles it possesses. So does it move fast, does it move slow, or just like medium? And then based upon the distance between the particles, is it too close, very close, or is it too far? Okay, so these three will be used in order to classify matter into solid, into liquid, or into gas. Okay, so I think you know already what are the examples of solids. So like for example, your glass, like your mobile phone. These are example of your solid. What else? Your table there, your table. There are lots of things here. You have your rock here. What else? We also have right now, if you're holding your book is an example of your solid. Next, if you feel thirsty and you want to drink juice, or maybe not juice, or maybe water. Okay, what else? Another example will be like your rain. It's also another example of your liquid. And then also we have your gas. So the air that we breathe right now, that is an example of your gas. You still remember our last video when we talk about steam or water vapor? So that's also another example of your gas. So now let's try to look at what's inside or how does these particles look like? Okay, how does this particles look like under the microscope for solid, liquid, and gas? Okay, so you can see here. So the particles in solid, the particles in liquid, and then the particles for gas. So as you can observe here, so the particles for solid, they are very close to each other. Okay, so for liquid, they are close together. They are close together, but not as close as the solids. So meaning there is still like tiny little spaces here that allows them to move. And then finally, we have your gas. So as you can see, the particles are very far from each other. So meaning they're not very close. So they're very far, so they can move around, hitting each other, and therefore bumping each other frequently. Okay, next. Let's now talk about the shape of your solid, the liquid, and gas. Since the molecules of or the particles of your solid looks like this, so we can say that the shape of your solid will be having this fixed shape, right? Since they're close to each other, so they cannot move around. Please take note that they are very close, but still they don't stop moving, right? There is so-called vibration, or shall we say shaking. There's still shaking that is happening here, even though they're very close. Okay, so the shape of solid is expected to be fixed shape because of their very close attachment. They're very close to each other. Whereas with your liquid, since they can move a little bit, they can slide a little bit compared to your solid, so liquid will not have or won't have a fixed shape. So no fixed shape, right? So let me just use some examples here. So going back with your solid, so since this straw is fixed, or I mean, since this straw is solid, so even if I steer it around, so still retain the shape, its shape, right? Whereas if you talk about your liquid, so I have here the green liquid here. So the shape of the liquid depends on the shape of the container. So this is the glass. So the liquid takes the shape of the glass. So I have here again the goblet. So this goblet, so if you pour this liquid into the goblet, so the liquid will take the shape of your goblet. Okay? So your liquid, since it has no fixed shape, so they can flow very easily. Okay? Because there's a less their attachment is not very close compared to your solids. And then finally, we have your gas. So with your gas, obviously, since they keep on moving around, so it is expected that it has no fixed shape. Okay? No fixed shape. So next, so I have here my syringe. Okay, my syringe is here. Sorry for that. Okay, so we cannot see that we cannot see air, but assuming that I have this syringe, so we can say that the shape of your air or the shape of your gas will take the shape of this syringe. So syringe is spelled as SYRINGE. So syringe. So the air or the gas will take the shape of the syringe. So if I pull this plunger, so the air will take the shape of the syringe. Okay, next. Okay, let's talk about its volume. So volume, so what do you think? Is it fixed or not? Okay, since it has a fixed shape, so meaning the volume will also be fixed. So the volume will not change. So like for example, so if you put something like, this is like the box. So I have here like the box here. And then shall we say, if you place like 5 circles here, 5 solid circles, 2, 3, 4, 5. So even if you shake it, still you will have the same number of solids, right? You will still have the same number of circles here, which is 1, 2, 3, 4, 5. Okay, next. How about with your liquid? So with your liquid, So even they slide or even they move a little, still they have a fixed volume. So they will still have a fixed volume. So they don't change. So let me just use my syringe. So my syringe can hold up to 35 ml. So I will just push until 10. So I'll just use 10. So just use 10. 10. Actually, you can do this experiment at home. So means when I pull the liquid, so it's not perfect, so it has air. So let me just remove the air for you. So we can just stick this one and remove some of it. Okay, so I don't know if you can see clearly in the video. So I have here like 10. So there's still space here. So if I press this one, just push it a little. I'm afraid that my notebook will get wet. Okay, so I just push it a little so I cannot press it. So see, so even if I push it, so the amount of liquid does not change. It's still 10. So this is the reason that we can say that the volume for liquid is still a fixed volume. So I get 10 ml of liquid from this goblet, and then when I try to push the plunger of the syringe, it still appears to be 10 ml, 10 milliliter. Okay, so that's a fixed volume. Okay, let me just remove the water. Okay, how about your gas? What do you think? Does it have a fixed volume? Does it have a fixed or no fixed volume? What do you think? Okay, so let's try or let's do some experiment. Okay, so assuming that I'm going to pull the plunger, okay, plunger down, so that I will get here 35. This is 30, 35. Okay, now, do you think how much air does this syringe can hold if I'm going to push this plunger? Do you think it will be 35, just like with your liquid, just like with the water, the green water? When I push it, it's still 10 ml. Do you think if I push it right now, it will be 35? So I'll be closing this one when I push it. What do you think? Okay, so let's do the experiment. So right now, I'm covering this one. So if I push the plunger, see, and so see, the plunger is still moving. It's still moving even if I close it. So right now, so how much air is left there? So it's around 20, 21, 22, 33, 24 ml of air. See? So therefore, there is no fixed volume of air unless you compress it. So if I release it, you can hear like a shh sound. I don't know if we hear that one. Okay. So we can say that the volume of your air, it's not fixed. So there's no fixed volume. There's no fixed volume for gases, right? You will know its volume when you press it or when you compress it. Okay? So next, I hope you understand that part. For volume for solids, fixed volume, liquids, fixed volume. For gases, no fixed volume. Okay? Next. So next we will go to the arrangement. So what does your particles look like? So I think you have already an idea. So they are very close to each other. They are close to each other. They're very close to each other, and then they are not easily compressed. Not easily compressed. So again, this is pull and push. Compress is like you can say push. Okay, the word push. Where's my marker here? Okay, marker's here. Okay, the word compress can be, we can say like push. Okay, so not easily push or not easily compress. Okay, next we have your liquid. So they are close together. So they are close together, but not as close as your solid. And then we also have your gas. So as you can see here, there's no arrangement. You cannot define it. Do you think the arrangement will look like square? Because they keep on moving around. They are very far from each other. So there's no far from each other. So there's no particular arrangement. Far from each other. Far from each other. I shall say very far. Let's just add the word very far from each other. Okay, next. Okay, how about the movement of particles? So with this one, we will do the experiment on page 5 of your book. So when you do this experiment, always remember that you must read what are the objectives. Objectives are the goals. What are the things that you're going to do? For any experiment that you are going to do, expecting that this subject is science, so we'll be dealing lots of experiments. So you have to know the goals. What is the target? What do you want to learn when you're doing this experiment? Okay, that's your objective. Problem? So problem is like, why are you doing this? Why are you doing it? Why are you doing it? Why are you doing it? So it's the question is like, why are you doing it? Why are you doing this experiment? That's the problem. So we want to know the bond, meaning it's arrangement. Can be like arrangement. Okay. How does or what is the arrangement of these particles? Again, the particles, the circles, the molecules, atoms of solid, liquids, and gases. And then hypothesis. Hypothesis is your educated guess. Educated guess, meaning we could say like, what do you think? What do you think is the possible answer? What do you think is the possible answer to this question? Okay, so what are the problem was like, how are the bonds of particles in solids, liquids, and gases different? So what do you think is the answer to this question? So I will give you this one as your homework. So you will be the one to answer this one. There is no right, there is no wrong answer in hypothesis, because that's the purpose of doing your experiment. That's the reason you do the experiment. You want to know, you want to answer the problem. So even if it is a pass, even if it is a fail, because in experiment it's normal to fail in experiment, but in failure you don't have to stop. You have to do it again until you can get the correct answer for it. Okay, so next. Okay, so of course we have your material or equipment or material. So right now I'm trying to save environment, so instead of using plastic bottle, so I'm going to use glass. Okay, so then we can also use, let's have this glass here, glass, and then we also have your foam beads. Okay, your foam beads. So actually you can buy this one from educational supplies. So as you can see, it's only 20 baht. Okay, so these will be the particles. These foam beads or the particles. Okay, and then we also have here your rubber stopper with gas pipe. So you can look at the picture in your book, but for my case, I don't have this rubber stopper and gas pipe. So I just use like plastic. Okay, I just use plastic to, to act as my rubber stopper. So the rubber stopper or the plastic is used so that when I shake it or when I flip it around, so if I flip it around, so okay, okay, majority will not, the majority of the balls will not fall down. Okay, and then your gas pipe here. So this will be the gas pipe. So what do you think will be the function for this? So we will know it later. Okay. So here's the simple activity. So what I did was that I just got the bottle, make sure it's clean. So I'm very sorry I used this one already. So, but okay, it's here. Okay, so you just open this foam beads, just fill it up. So depending on the glass that you're going to do with it. Like for example, if this glass is for solid, this glass is for liquid, or this one is for gas. So like for example, so once you fill up the glass with beads, so you're going to cover it with plastics. I use tape. I use tape to tape the side so that the plastic will not be removed or won't be removed. And then, so this one, as you can see, the glass is full. So this one will be your solid. Because remember that in solid, the particles here are very close to each other. This one is your glass or liquid. You can see there's still spaces for these particles or foam beads to move around. And then we also have here your gas. Since they move very far from each other, so that's why there should be less contact. They should not be very close to each other. Okay, so here's what you're going to do. So on your page 6, okay, of your Mastering Science 1A, so we will be trying to answer the questions here. How does the foam beads or how foam beads move when blown? So therefore, blown. So meaning we will use this straw or gas pipe, if you have there, to blow air into your glass, or if you have a bottle, it's okay. So if I want you to observe if when I blow this one, so if I try to blow, I'm not sure if it's very clear to you, but I'm trying my best to move it very close. I'm blowing it right now. Sorry. Okay. See? So you cannot see that there's movement of your particles or foam beads in your glass because they're very close to each other. Or maybe you can see that there's like movement around here, only in this part, but the rest of the foam beads will not move because they're very close to each other. Okay? Next, how about the half bottle? This is the half bottle or half glass. So if I blow this, I blow the air for this, so see. Okay, so they can move around because there's still enough space for them to move. But how about for your liquid? This is, for gas, your 1/4 of the bottle or 1/4 of the gas. So see. Oh, sorry. Okay. Okay. So since there's a very big space compared to your liquid, so the foam beads of your glass can move further compared to your liquid. Okay. So if you want to do these experiments at home, so it's easy. All you need is only like the plastic, the glass, and then the straw. If you don't have foam beads, you can use stones, tiny stones or pebbles, and then don't blow it, but just shake it. Okay? It's still the same. The function will be the same. Okay? Very good. So for this one, I will give you this one as your homework. So you will be the ones to answer it. Okay, next. So what do you think will happen if you raise this temperature to super high levels between maybe 1000 degrees Celsius to 1 billion degrees Celsius? So what do you think? So will everything will just be gas? So the answer is no. So that gas, superheated gas, will become your plasma. So your plasma is defined as your ionized gas. So this, it's not only three now, this is like an extra information for you. So there are four. So the fourth state of matter is your ionized gas called plasma. So when you were like in grade 6, I think you learned about electricity, and you've learned about this symbol, the plus named proton and the negative named electron. Okay, so with this one, so if gas moves very far and very fast, so can you just imagine how fast this plasma moves around, right? So just like the gas, so there will be no fixed shape. No fixed shape. For volume, just like the gas, just like imagine a superheated gas, so there will be no fixed volume. For the arrangement, it will be very, very far from each other, And then for the movement, so basically they will move very fast, right? Very fast movement. So this plasma can be seen in your lightning, this one, in your lightning, or if there's like a bomb that is being dropped, so you'll have your nuclear fireball, okay? Or even the sun. The sun is super hot and it produces this ionized gas called plasma, okay? So activity, so I think the video is very long. So let's do it fast. Guys, what do you think? Solid, liquid, gas? Okay, it's solid. Water. Solid, liquid, gas. So it's liquid. Okay, next we have chocolate. Solid, liquid, gas. Okay, it's solid. Okay, next. Milk. It's liquid. Okay, steam. What do you think? Steam, or water vapor. So it's gas. How about tire? Okay, it's solid. Okay, next, carbon dioxide. It's gas, rock. Okay, it's solid. Okay, honey. Okay, it's liquid. Okay, wood. Okay, it's solid. Juice. Okay, it's liquid. And finally, we have your air, which is your gas. Okay. So I will be giving you this one as an extra activity. So it is a solid, liquid, or gas. So all you have to do is to describe or use an arrow to like, for example, doing like this. So this one is solid. This one, the inside, you have your liquid. You can do like this now. Okay, just right there, the milk. Okay, so this one, these are not bubbles. Okay, these are not bubbles. So these are smoke. Okay, smoke. These are smoke now. So this one, and smoke is an example of your gas. Okay, so you can pause this video to think and write down the answer in your notebook or into your book. Okay, homework. So homework. So since you are already grade 7, so I am expecting you to answer page 6. Okay, page 6 and page 8 of your book. Answer only number 2. There are 2 numbers. So you just only answer number 2. So for number 2, there will be 3 tables there. So if you want to watch the video again to complete this table, you can just visit the site to where this video is uploaded. Okay. So if you don't have any questions, or if you have any questions, you can send your questions to me through this Gmail account. That's sherwin.taklong@gmail.com. So that ends our lesson for this video. So I hope that you've learned a lot of things from me, and see you again in the next video. Okay, thank you and have a nice day.